SensoDuino is an Android application that harvests the sensors built into your Android device. Most Android phones contain sensors such as accelerometer, maybe temperature, gyro, voice, which is a microphone, magnetometer, compass, and GPS for directions, and more. Different Android devices have different combination of sensors. I'll be demoing SensoDuino on a Samsung S2 Plus. This is SensoDuino running on a Samsung S2 Plus. So on your particular device, you may see a different combination of sensors. So if I run SensoDuino without enabling GPS, assuming my phone has GPS, and without enabling Bluetooth, I will get a warning reminding me that I need to enable GPS and Bluetooth before I run SensoDuino. So let's exit, and if I need to log GPS data, I need to enable GPS before I run SensoDuino, and if I need to transmit SensoDuino's data to a PC or an Arduino, I need to enable Bluetooth also. So going back, now we run SensoDuino. Now for Bluetooth to work, it assumes that I have already paired the Bluetooth device of my Android to my target Bluetooth device, whether it's an HC05 connected to an Arduino or a Windows PC equipped with Bluetooth. Okay, so this is the interface for SensoDuino. It's very simple. You have a list of available sensors. The ones that are grayed out means that they are supported by SensoDuino but are not available on your particular device. Okay, the ones that are not grayed out means that they are available on your device. We have, of course, sensors that are hardware sensors, and you have sensors that are software sensors developed by the folks at Google to basically take the raw data generated by hardware sensors, combine them, smooth them out, control drift, and things like that. To find out the list of sensors supported by your device, just go to the Existing Sensors tab. The Existing Sensors tab will list all supported sensors on your device, and this list may vary from an Android phone or tablet to another. Some of these sensors that are listed here are hardware sensors. Some of them are actually software sensors per se, developed by, for example, Google, to combine multiple sensor data to produce more useful sensor information for the users. Some of these software sensors are also designed to control drift in some sensors, to control spikes and erratic sensor readings. You can see here, for example, the rotation vector sensor is vendor. It says vendor Google, and that's basically a software sensor per se. So let's see, starting with the sensor number type 11 here. These numbers, the type of the sensor is actually a number provided by the Android SDK. So these numbers are official sensor numbers, and throughout SensoDuino we refer to these numbers as synonymous with the sensor name. So whenever you see type 11, it's a rotation vector sensor for this particular vendor. Whenever you see type 10 sensor, it's a linear accelerometer sensor. Whenever you see a type 9, it's a gravity sensor. Each sensor has a type or a number associated with it, and you see a list. The list also contains the vendor, the version, the resolution, the maximum power consumption, the maximum range of reported values, and the minimum delay in microseconds to read this sensor. Okay, so going back to the sensor log, the screen is fairly simple here. So you have the list of sensors supported or not supported. The ones that are supported, next to them you have 3 columns of checkboxes, and these checkboxes are on to turn the sensor on or off, TX for transmission, to enable Bluetooth transmission of a given sensor, and of course a log to help you save the sensor data to a text a comma delimited text file on your SD card. And of course, to be able to take advantage of the transmission and the login, you have to first enable the sensor. Now, since I am indoors, I won't be getting any GPS readings, so I'm just going to disable the sensor. Okay, so right now I am reading orientation and gravity. So let me enable all the sensors. Okay, now to know the units for these sensors, you refer to the documentations. Sometimes the units are listed next to the sensor type. Sometimes you just have to go to the help menu. From the action menu, you go to help. And here you'll see a list of sensors and their associated units. Like I said, the numbers that accompany each sensor are Android SDK numbers. So here you have acceleration units, you have magnetic field units, you have degrees, you have lux, you have centimeters, and therefore. Okay. Some sensors don't really have units, such as the audio sensor, which is really just a generic loudness measure. So you can basically decide what the value means, what the silence mean in a certain environment, and what's noise in a certain environment. So for example, the audio will just spit out readings from 0 to 32,000 something, or 2 to the power of 16. So if I go quiet, and if I start talking again, and if I speak louder again, so there you have it. These are generic values. I can decide what they should mean to my application. The proximity sensor, on the other hand, really tells you whether there is an object within a certain range or not. In this case, for my phone, if there is an object detected within 5 centimeters, I will get a reading of 0. And here it says nothing within 5 centimeters. There is something within 5 centimeters, nothing within 5 centimeters. Okay? It may vary from one Android device to the other. Now, I can also control the speed of reading and transmission and logging for a particular sensor. So the way to do that, I go to the action menu, I go to preferences, and here you see a list of all the sensors. And suppose I want to increase the speed of the orientation sensor. Here I have these default choices that I can pick from. I have 100 milliseconds, that's 10 times per second. 250 milliseconds, that's 4 times per second. 500 milliseconds, that's twice a second. Let me go full throttle. So now, the orientation sensor is reporting at 10 hertz, that's 10 times per second. So now, the orientation sensor, of course, the reason yaw is not changing because I'm pointing in the same direction. Actually, none of the other readings will change significantly because my phone is stationary. So now, if I wish to start transmitting, assuming I have another device that I've paired with, all I have to do is just click transmit. And if I'm not connected to the paired device, I go to the options menu and I just connect to a particular device. Okay. At the same time, I can also log the readings of the sensor to a text file called SensoDuino.txt that's saved in the root directory of your SD card. I can delete this file, delete log file, so we can start again, and reset the counter. The counter, of course, is meant to keep track of how many sensor readings have been logged. This is helpful to tell you, of course, the total of sensor readings, as well as if there are any missing sensor readings. That's usually a sign of dropped sensor values. So if I start logging now, right now it's saving the text file. So if I stop logging and then go to my file manager, SensoDuino.txt, it's in the root, and if I open it, these are all orientation sensor readings in a comma delimited format, and you can import it into Excel to do analysis or to plot some graphs. And a typical sensor reading starts with the sensor name and then the count, the log count, 158, 159, 160, 161, 162. Then of course X, Y, Z. There are 3 values per reading, and an accuracy for that sensor. 0 means everything is okay. When the number increases, that means there are problems. Okay. So some of the things that you can also do, we have, like I said, you can delete the log file, reset the counter. You can connect to a Bluetooth device that you have already paired to previously. You can make your Bluetooth discoverable. And preferences, one more time, this is where you go and you change the frequency of reading per sensor, subject to the limits of the sensor's manufacturer specifications. Sometimes if a sensor is slow, such as GPS sensors, they usually report location data at 1 hertz, that's once per second. Some GPSs actually report location at 10 hertz, 10 times per second. So, if you select 100 milliseconds, you're really not going to get more accurate GPS readings. You're just going to get repeated readings of the same location 10 times a second. At the bottom of the preferences list, you see there's a feedback form. If you're connected to the internet, you can actually send me comments, feature requests, bug fixes, etc. There is a built-in crash reporter for SensoDuino, so whenever it crashes, it will open up a form asking you for your permission to send the crash data to help me improve the application, and it will open up a little dialog box where you can actually enter some comments if you have something to suggest about SensoDuino, or how to fix this bug, or how to improve performance, or things like that. And I think one more thing to keep in mind, if while you're working with SensoDuino you see the label turning red on some of these sensors, that's an indicator, a visual indicator that the quality of the reading has dropped. It's just a built-in feature that I've added. Again, I decide this by extracting data available through the SDK, the Android SDK. It tells me that this reading is less than ideal, so I turn the readings into red, and that's a sign for you. But the log file will contain a value for accuracy that you can use to decide whether you want to keep the sensor data or to discard it in your calculations.